So I know I've got this sinusoidal. I know that the temperature repeats every 24 hours. So let's set up a day. They're telling me that the high and low temperatures are 47 to 53. So I mean 43 to 57. The average is in the middle. And I don't know what that average is. They aren't telling me that. But it's going to be the midline of my sinusoidal. And so they're telling me the temperature is 50 degrees at midnight. So I'm guessing that's going to be the average. Now the way I can check is that's 7 above, or 57 is 7 above, and 43 is 7 below. So I know a couple things out of that. I know the amplitude is 7. I'm also knowing that let's see, it happens at midnight. So there's midnight, and then if we think about what happens here with the sine graph, I've got this. Now they aren't telling me to use a sine or a cosine graph. I'm looking at this and I'm seeing that point in the middle is nice. Then it goes up and it goes down. So to me that looks like a sine graph that's been shifted to the right 12 units. So that's how I'm going to approach this. I know the amplitude is 7. I know it's a sine graph. I know that it's been shifted to the right 12. I also know it's been shifted up 50. And then to get the period, I know that normally sine it repeats every 2 pi units. This is repeating every 24 hours, so that becomes pi over 12. So that is the transform trig function that models this. Since I'm recording a video about modeling with trig functions, I decided I would also do one from later in the section, or later in the chapter, from 6.5. So it's the same kind of idea. These temperatures repeat every 24 hours. And I know there's going to be a minimum, I know there's going to be average, I know there's going to be a high. They're telling me the high temperature of the day is 63 degrees. So I know the high is 63, and I know the low temperature is 37. And the low temperature occurs at 5 a.m. So just a little bit before 6, which is the normal turning place, I know the low temperature happens at 5. So then if I think about this midline and how these trig functions behave, I know that 6 hours later it's going to be at the average. 6 hours after that it'll be at the high. 6 hours after that it'll be back at the low, and then at 5 in the morning again it'll be back down at the low. I'm sorry, I said low. This should be the average. So here's what I'm seeing for a sine graph, or maybe it's a cosine graph. I'm almost thinking it looks like an inverted cosine graph. I mean, you could do a sine. I'm just going to talk about this in terms of cosine. I know the amplitude is, let's see, what is that? So we don't know. They didn't tell us what the average is, so we got to figure that out. So I know that these two numbers are how far apart. Let's see, is that 26? Let's see. 3 makes 40. 20 more makes 60. And 3 more. So yeah, so that averages, I'm losing it. Let's see. Now, what did I just say, 26? So that's going to be 13 and 13, so that would make this 50. The average temperature would be 50, and that checks with the high and the low. That tells me the midline is y equals 50. I'm thinking that it's a shifted cosine. It's also shifted. Notice the other one was at midnight. Now it's shifted right to 5 a.m. So I'm going to think, and it's an inverted cosine because typically cosine starts up above, right? So I'm going to write negative 13 is the number in front. Negative to make it inverted, 13 because it's amplitude. I'm going to say it's cosine. I know the period is going to be 24 hours still, and 2 pi divided by 24 is still pi over 12. So that's nice. And then this has been shifted right 5 units. So make it minus. And the midline is 50. That's a 50. That should be a 50. I'm running out of writing space. Let's see. Can I fix that? So plus 50. So I think that's the trig function that'll model the situation. Hope that helps.